Okay, so I'm going to go ahead and jump into it. I've got about 30 minutes of content to cover in 25, so I will try not to blow everyone's hair back while I'm covering all this content. First thing to say was just I'm super excited to be here. I'm a Dallas born and raised, so I feel like having a conference in this awesome city is super appreciated, so thanks to the organizers for doing that. What we are here to talk about today, just to frame it in everyone's mind, is not an R&D concept. It's not some new idea that we're thinking about doing. This is a deployed product that large companies such as BMW that we can talk about publicly, I'm very happy to say, have built entire ecosystems of 3D model sharing, creation, and management across their organizations. So you can see up here in this image some examples of marketing stills, renders, 3D models, CAD, BIM, point cloud data, et cetera, could all be loaded into this system. And that is what we are here to talk about today, is our asset manager system. So the title is Optimizing CAD and BIM Data for Anyone on Any Device, because that's one of the things that we've always been good at Unity, is pulling in data with our Pixies platform, whether it be CAD, BIM, point cloud, or even unoptimized polygons. That product has now been renamed to Unity Asset Transformer. So anytime that I reference that, just know that I'm using it interchangeably with Pixies. We want to take that and really democratize the 3D data across an organization and stop locking a source of truth file behind a silo in one team with that one engineer that has to go into the PLM, pull it down, and then decimate, tessellate, do whatever needs doing. So our agenda for today is going to be a brief intro of why am I even up here on behalf of Unity and talking about this, going through existing challenges and what we're hearing from our customers that is driving us in the direction of creating a tool to do this. What is the asset manager, just defining it, what's the value prop, and then lastly looking at 2 to 3 different demos that we can walk through here today. So I'm Cam, based out of Dallas, Texas, as I mentioned. I'm the senior manager of our solutions engineering team for the Americas. So that means everyone on the team that I manage travels around North and South America, working with customers day in and day out on things like data pipelines, interactive content creation, deployment to various types of hardware, et cetera. So we're kind of the technical team there. I am up here, frankly, because I've personally been the decimation station, as some of my colleagues call it, or the retopology guy in a pipeline at companies. I actually came to Unity from Bell Helicopter, where I managed the industrial design team working on new concept aircraft, interiors, styling, human factors, VR flight simulators, that sort of thing. And I just so happened to be the one person on the team that knew Blender and Maya really well. So I had the VP at my desk a lot asking for me to find the new tail rotor, for example, and this is a true story. Pull down the tail rotor, give it to him on an app so that he could show it to his boss by the end of the day. So that would immediately become top priority. I would go talk to the one engineer that I knew understood Enovia, our PLM system, to pull the data down. That engineer would then convert it into a step file, which is good and bad because it was an interchange I could work with, but it ripped all of the intelligence out of the file. The metadata, anything that I could have used to create an automated pipeline to automatically assign materials or otherwise was gone. So I took that step file, went in and retopologized it a bit, cleaned it up, then took it into Substance Painter, painted materials, UV unwrapped it, did all that stuff, took it into Unity, built a very simple APK where you could spin it around and it looked nice and clean. Take it to the VP's desk and he spins it around and says, this looks exactly like I wanted, except this is the wrong tail rotor. And I need you to get the design from this morning, basically. So with that, I go back to the engineer's desk, we restart the entire pipeline, wastes an entire day of my time. So it was a rough go of it, and I personally understand the value of what we're talking about here today around having unified asset management, sharing, role-based access controls, and everything that comes with it. So what were we hearing? Really, we were hearing that teams were wasting time, money, and energy searching for data. And frankly, I can personally say not only searching for, but also recreating that data, or in the worst case, paying an agency to recreate that data for us when we already had it sitting in a NAS repository somewhere that no one knew existed. The other piece of this is laboriously converting those files and getting them to look good and have good topology and pull through a pipeline and ensuring that the right people have the right access to the right types of data. Another quote that's not on here that I like to mention was a quote from one customer that was, "Why is it easier for me to track what stage my pizza delivery is at than it is for me to know where my assets are for my aircraft?" So what are teams typically doing today? They're typically building short-sighted storage silos. So what that means is you have a team of 5 marketers that have their NAS or their repository of 3D data. You have a team of 10 innovators that have their own repository of data. You have the engineers that have their repository, so on and so on and so on. And what ends up happening is that these teams, at some point in time, are bound to collide with having the incorrect file at the wrong time. And it's not the right version. True story being giving let's say a helicopter to a customer and it not being the right shade of orange because the paint vendor did not have their hex code matched with our marketing team, which did not have the right list of which paint colors the engineers approved for the aircraft. That type of stuff we saw often, and it was all due to these short-sighted storage silos. The other thing that we'd see is piecing together a lot of different types of brittle scripts and systems that work really well for 2 or 3 or 4 people on a team for maybe managing a product or 2. But the reality is that we didn't, at that point in time, we would get beyond, let's say, 1 product or 3 or 4 people, and we would then see these cracks in the walls of this infrastructure that have been created. And by the time that you see these cracks, you realize that the foundation is already flawed, and at that point, you just have to throw away the system that you built, is really what it comes down to. Lastly, we saw folks trying to get by with traditional 2D dams. So everyone in here knows of GitHub. They are a great system, and they work in a wonderful capacity. But the reality is it was a system that was made for 2D data and scripts and pushing and pulling. Yes, you have things like the large file system, LFS, that you can install, and it works great. But the reality of that is that the system wasn't built from the ground up to handle large 3D data. And what we're talking about really is. That's the entire intention. So what is Unity Asset Manager? It is a cloud-based digital asset management solution that streamlines how teams can upload, manage, transform, and share their data. One really important caveat on this slide is that yes, it's called Unity Asset Manager, but the reality is that it does not care if you're working in a Unity project. So you can be pulling in data from Blender, as I'll show in an example in just a bit here, through an integration created with the SDK that comes with this tool. And you can create integrations out to anything, Omniverse, Unreal, whatever you need to be using. So I don't want anyone to read this and think, well, we don't use Unity enough to warrant this. It truly doesn't care. The system is agnostic. For product features, they typically fall into asset discovery. So being able to search and browse your 3D assets, connecting to external content repositories, so things like PLM systems, you can create integrations directly into those. You can even leverage the Asset Transformer SDK, that's kind of the engine running behind this front-end web DAM, and you can create something like a folder watcher that will watch your PLM system and wait for commits from your engineering team to then pull down, tessellate, optimize, and then push up to your asset manager as a service. Asset management, so the ability to upload, categorize, and share assets across your team with role-based access controls so that you can control who gets to see which types of tiers of data. Then you have asset transformation. This is what I get most excited about because it effectively removes the need from having someone to sit at a computer day in and day out, pulling in CAD data, tessellating it, optimizing it, and then exporting it, because it can do that for you in an automated fashion when you pull the data into this asset manager system. The last piece here being asset storage and security, and the fact that this is a multi-tenant cloud storage system and can work within virtual private cloud of Azure or AWS today. So if that is a need that you have, that would exist within your tenant where we would have no visibility of the data. This also supports IAM integration, and the last thing that I would say on this slide is that you are able to also lean into the security aspect of 3D data pipelines by inherently decimating or defeaturing data intentionally as it gets further and further from your engineering team. Frankly, I don't want my marketing team to be able to see what metadata was paired with which pieces of an aircraft or a car. I certainly don't want that going to an agency. So at that point, I would be tessellating it, decimating it beyond replicability back to the intellectual property, and I can also handle it that way. So industry workflows, we typically, when we talk about Unity, we'll see folks think of Unity Editor and the runtime. So typically, you hear Unity, you think about C# scripts, ingesting 3D data, lighting, post-processing effects, and exporting out to an APK, an executable, a WebGL link, whatnot. That is a core piece of what we do as a company, but the reality is that we have other pillars that operate as importantly. So we have Asset Transformer over here on the left. Again, that's the new name for Pixies. That is where all of the data can be optimized, converted, and exported for you. Asset Manager is really what we're talking about today, our solution for a dam. And then we have version control or Unity version control that can handle entire project hierarchies, pushing and pulling, data locking, and all of those types of things. So again, we're focusing on Asset Manager today. So the one thing that I'll point out is that Asset Manager does not currently have a check mark next to on-premise, as you'll notice. Our other two main pillars do. What that means is that as of today, it is available on private and public cloud, but it is not available on-prem. If you see this and you say, wow, this really would have been useful if it could have been on-prem, come and please talk to us, because all of that does is give us ammunition to relay back to the product team, and then they can prioritize that appropriately. So in a workflow, we have 3DCC tools or asset stores, typically where you would get polygons and start pulling those through into the Unity engine. That's content that's made for the engine that you can immediately pull in. It's usually already tries or nice topology. Within what we typically see in industry or non-gaming, you have the opposite of that. You have CAD, BIM, point cloud, PLM data that can go through Asset Transformer or Asset Manager. And the nice thing is if it goes into Asset Transformer, you can do a lot of very deep Python and C# based actions in the background and run it as a service and things like that, then push to the Asset Manager. Or if you go directly into Asset Manager, because it's built on top of Asset Transformer, you can effectively run a lightweight version of that through some node-based processes that you can optimize as quickly as you can without needing a 3D artist in the loop. From there, Asset Manager can push into Unity Editor, where you can then use additional services that we have as well, and then immediately distribute that out to your VR and AR devices, mobile headsets, and whatnot. Looking at the time, I'm going to speed up a lot. Main value props being flexibility and extensibility, the fact that you can create an integration for any other software, but that we also have a Unity Editor integration that ships with this that you can immediately access through a package that has full awareness of prefab, scenes, and other game engine specific type assets. And also multi-platform support, so that we support over 70 different file types that can be pulled through. I am going to skip the next 2 slides, just looking at the clock, and go straight into 3D data streaming, which is a new technology that is being delivered along with this. What 3D data streaming fundamentally is almost a combination of GIS tile mapping with hierarchical LODs, meaning you can feed it a massive, massive file. Frankly, we've been able to get files to load at runtime in Unity that you can't even open in the native software that created it because it's so dense at this point. And what it does is it takes that scene and it fractures it into a bunch of sub-components and parts that each get LODs assigned to them. So as you move the camera around the scene, only the data that you need is being streamed into the runtime of what you're running. So this would be an alternative to something like GLT Fast, an immediate runtime loading of assets. And this can be pulled directly down through Asset Manager if you have your assets stored in Asset Manager and 3D data streaming enabled. So what we're looking at on the right here is actually a build of a public project repo that we have on GitHub that anyone can access today. And this one is built out into an executable, but 3D data streaming is also supported by XR, mobile, web. And what we're seeing is 4 different warehouses, each warehouse, or rather 4 of the same warehouse, I'll say, each of them being over 60 million triangles and over 10,000 parts. And we're able to load them, and you can see that we're getting virtually no lag in the experience whatsoever. This also has other features like Vivox for voice chat and multiplayer built into it if you want to use those. But the idea is that you can now get in here, go through this environment very quickly, and as the camera rests, you can then see different levels of detail load up or down. And I did have a colleague take a scene just like this, load it onto something as lightweight as a Samsung smart fridge through a URL, and was able to spin that thing around in real time. We also have high-level optimize and convert, so you can do things like immediate polygon target decimation from directly within the browser. You don't need to export or exit to anything else. As well as automation and pipelines, where you can create pipelines for different types of data. So if you process warehouses versus cars versus engines, you're going to want different rule sets kind of analyzing the scale of what data you're pulling through. And this is what that system looks like. So it's very node-based and can effectively use anything that you have made previously in Unity Asset Transformer or Pixies, and you can run custom scripts or use the default nodes that are built into here. For demos, I'm going to go ahead and jump into demo 1 of 3. It will, looking at the clock, run past the time that I have here, so please yell at me if I need to. Okay, cool. I have a thumbs up to proceed, so we shall. So this first one that we have is an example. As soon as it goes, there we go. This one is an example of integrations. So specifically, I'm looking at this low poly radial engine that we're dealing with. And this engine I've created through topologizing that, or rather tessellating that and optimizing it within the asset manager. We're going to take that and use the integrations both in Unity and the Python integration with Blender that we've created as a sample for you to use. So in looking at this, we have the radial engine implemented into a scene in Unity. It's operating as a prefab, and you can also see that it exists within the asset manager window on the right-hand side that was pulled in as a package. If you select that asset, you can immediately see things like source file if you choose to grant access to those types of files to your end user. We can also see over in Blender, where we're saying that the source file is coming from, the integration working here as well. So I'm going to make one very quick visual change, just going from green to red of the rotor itself. Now that we've made that change, I can go up to the plugin and say, go ahead and push this up to Unity Cloud. And in doing that, I can then pick the organization, the project, and basically say exactly where I want this to live. Do I want a new asset, or do I want a new version of an existing asset? Do I want to embed the textures, so on and so forth? There are many settings that you can get in here and configure. So once I've selected all of that and hit OK, it's going to open up the asset manager within a browser and show me that the visual change has been pushed. So I can see that the color is now updated. I go back into Unity, look at the project inside of the window here on the right, and see that there's now an icon saying, wait, this is out of date. So from here, I can either update every asset within this project, or I can go over into the versions or push forward or backwards from this panel. And if I want to, the easiest way is just to go back into the main asset and say update to latest. So I'm going to hit update to latest, go ahead and say yes, I'm aware of what I'm doing, and hit OK. We're now going to see that visual change happen in scene, but more importantly, what's happened is that it's pushed that visual change to the prefab. So if I had this engine in 500 different scenes, each with a different training module, all of them will have just updated, because it's all working off of the prefab system. The second demo that I have is going to be looking at pushing a piece of 3D data up into Asset Manager. So we're going to do this helmet, and I just want to show that it is not smoke or mirrors. This is truly a BREP, non-tessellated piece of data. As I turn off BREP representation, the screen goes blank. So that is a solid part file. I'm going to go ahead and hit Add and select a file that I want to add here. I can either add from Unity version control if I have that in my ecosystem and I'm using it to version my projects, or I can just upload from my hard drive. So I'm going to choose to upload from my hard drive, select the solid part file, and go ahead and hit Go. When I do that, I'm not clicking any other operation, but a bunch of things are being kicked off for me in the bottom right. And that's because it's detected that this is a parametric data set of one of the 70+ file formats that Unity Asset Transformer supports. So what it's doing now is it's uploading the file, It's tessellating the file, it's optimizing it, it's exporting it as a previewable WebGL file so that my designer can now look at it in 3D and spin it around. It's also creating thumbnails for me so that I can see this immediately visually within the asset manager. So all of these operations are going to finish out, and as they do, we can see the baseline preview on the right, but before we open those up, I just want to kick off one operation using the optimize and convert that we talked about. So in doing that, I won't go through what each of these are for the sake of time, but I can effectively toggle all of these on and just force this down to whatever level of quality I deem appropriate. So in this case, I'm going to make it 25% of the existing geometry. And I'm going to say push this down, rename it to this new asset, and let's make it a USD file, because maybe I'm going in Omniverse in this case. Now that that's kicked off, let's hit save and let that run in the background while we look at the previews that were just generated for us previously. So this is the helmet asset. It is now tessellated and it's in a GLB file format that my designer can review. So the key value of this is I didn't have anyone put a single finger on the keyboard, and I didn't have anyone that had to have very specific experience with retopologizing, 3D modeling, or recreating this asset from scratch. And now I can have a design team give immediate feedback that can go directly to the engineer to make changes in the engineering file and then do this for a version 2. So we can see the different files that have been uploaded, as well as the source files. We see the different thumbnails as well. And we can see a history panel here, just as we did in the Asset Manager for Unity Editor plugin that we looked at in the last vid. I can also see comments here, which is one of the core value propositions that we'll see in the last demo that we're going to look at next. But the idea is that this is an easy way for us to relay feedback, whether that be to the original engineer that pushed the data, to an artist. We can then send that feedback and say, hey, try green on this next and re-upload, please. And then we can see that the output of our algorithm that we ran to optimize and convert took this from 10.5 meg to 175 kilobytes while we looked at a 3D model online. So all of that was done without us having to do it ourselves. The last thing that I will show here, and then I will wrap up in one more slide, will be some of the features that you can access. This video is probably a week old because these are brand new features that have just been released. And these are our collaboration features. So I can go into the hierarchy that's preserved from the assembly file of this radial engine. I can specify specific pieces within the hierarchy and isolate those out to talk about in a design review, for example. I can also go in and I can review which materials or textures are in here through a material override panel if I need to see the ambient occlusion that's come through the normal maps and that sort of thing. We can also represent wireframes here, and we can change the color of the wireframes to better have context against the background and some contrast that you can see easily. We also support a grid system, so you can get in here and start to see from a scale perspective what this is going to look like, as well as changing which axes your grid is on, as well as visualizing if you want to see things like the X and Y axes, and change things like opacity. So a lot of really great basic quality of life features here. One of the last ones is the ability to go between kind of more your engineering camera mode and your perspectives. So if you want to go into something that flattens your image out and see it from different perspectives, we have the pre-made cameras that will allow you to do that. And then if we want to go back into the perspective mode, we can annotate. So from here, I'm going to create an annotation as if I'm a design lead. I'm going to say, hey, I wish that this cone had this shape instead. So I'm going to draw it out for you instead of trying to type out what I think I want. Then I can even change the color, the size, the opacity of the brush, and draw in a few red swirls if I want. Clarify what I'm looking for in the comment. And then as I push this comment, I can tag the engineer that pushed the data to begin with, and it will automatically attach this image to the comment. I can then get in here and I can use the annotate tool again, but instead of drawing something out, maybe I want to use the arrow tool that will point to various pieces. And I can say, hey, I don't really love this color, just try something different. Maybe like a silver or blue, why not? Send that out, and now it's going to create a second comment, this one also with an attached thumbnail. Now the value here is that when my engineer comes back in, they can now hover over each of these, and it will snap the camera to the right position and preserve the edits that I've made and the visuals that I've added in. so there's no question about what I intended. You can also click on any of these and it will persist that image up in the viewer. So I will take questions after the fact out in the hallway just due to not wanting to run too far over. I did want to just make one quick aside and announcement that if you're seeing this and saying, wow, this is great, but the issue is that now you're scaling data access to my entire company and it's going to make my team of 10 engineers be under a giant workload and they're going to bottleneck with a bunch of requests from marketing asking for a new WebGL build or a turnaround or animations that I would have to integrate in Unity myself. The reality is that we're also addressing that with a new product announcement tomorrow at the keynote by our Sarah Lash. She is awesome. So she's going to be talking through that and how we're going to enable more and more folks to access basic interactions and creation of interactive WebGL projects immediately. For any session feedback, it would be much appreciated if anybody could please scan this QR code and give feedback. If you do, we also have some great Unity hats in the booth, and if you can just show them a screenshot that you filled out this, they will gladly give you a Unity hat. That is it for me, and thank you so much, everyone.